Hey guys, 12 through 15 here on the test. I'm going to kind of explain just quickly and just talk out loud while I think. After making the video for 8 through 11, I explain what these numbers are doing. So let's make sure that if you didn't watch that previous video, go through that. I explain pretty well on what is happening here. So let me snip this so I can write on it. So what this is doing is it's just backwards. It's actually just take some expression, be able to take expressions like this and see what was a simple number pattern that was started with right before it got transformed. So we're not squaring, like if you look at number 12 here, we're not squaring x, we're not cubing x, there's no absolute values. Okay, we're not taking 2 raised to the x, so it's none of those parent functions. This is actually just a line, right? We should be able to know that any pattern that's in this slope-intercept form is going to form a line. That would mean that our parent function is just x, right? Call it f of x if we want to. F of x equals x. Put in a number, get out a number. That's our parent function for a line. Then we can go ahead and multiply those outputs, and we can add and subtract values to it, right? So there's our parent function. If you look at this one, we're taking some expression with x and we're cubing it. So that means that our parent function is a cubic, right? 14 just says that we have some number raised to an expression here. So here's our parent function. That negative a, in this case, would be -1. That's going to flip our graph over the x-axis, make it now look like this, right? So it's not -2 to the x, it's just going to be 2 raised to the x. And then if you want to flip it, we'll multiply by -1. We can shift the graph horizontally 1 to the right by subtracting 1, and then we can make the graph move up 1. But we started that with this parent function 2 to the x. Okay. And then number 15 says, here's a graph, here's our parent function. We have to identify that that's the absolute value graph, right? It's not a quadratic. It doesn't look like that parabolic shape. Okay, it's not the cubic. Okay, it's not a line necessarily. It's this V shape, right? We have to identify that shape as absolute value. So there's our parent function. It's an absolute value graph. And let's see how it transforms. So let's look at this vertex point, this 0, 0, right? Notice now we're at the point here, -2, 1. So it looks like the point moved 2 units to the left, and it went up 1, right? So if it went to the left 2, h has to be -2. And then if it went up 1, k has to be 1. And then it looks like it just flipped, and the slope stays the same, over 1, down 1, over 1, down 1, right? That's the same slope as our parent function. So our a didn't stretch the graph anything. So what our expression should be, if we talk about our parent function as the absolute value of x, the graph shifted over 2 units to the left and up 1. So our expression would be the absolute value of x plus 2. We're subtracting a -2, and then it went up 1, so we say plus 1. So there's our new function that transformed this parent function to this new one right here.